All right, it's a nice gloomy day in Dallas. I've got my coffee, so let's do some coding. Today's going to be fun. We are going to production. So in my last couple of videos, we created a full stack application. You can check that out, full stack build, Node, Postgres, Redis, React. We created this full stack application that involves Node, Postgres, Redis, React, all working together. So that's really 4 different services: a front end and back end, database, and Redis. It's just a kind of a simple demo app where it can accept form submissions and display them here in this interface. So if I hit this generate submissions button, it queues a job in the background. I've got 31 submissions now, but if I refresh, then I have 41 submissions after it generated some fake ones for us. So this demos pulling these form submissions from a database, queuing them with Redis. This is a front end in React, talking to a back end in Node via GraphQL, all together. We got this running locally in Docker. And then in my last video, we converted it to a mono repo using Turbo Repo. So we got everything together in one repository. But everything's still just local right now. What happens if we want to move that to production? So that's what we're going to talk about today using my favorite tool for using this. This is not a sponsored video, though it could be if you wanted Render. My favorite tool called Render. Render is not just a tool, it's a platform. It's actually built on top of Google Cloud, and it simplifies a lot of the deployment management you need when pushing things to production. It's a very well-designed service, in my opinion. You can really tell they went to great lengths to make complex things simple within this service. So we're going to walk through how you would use Render to deploy a Node, React, Postgres, Redis application to the Render platform. Before we dig into that, I have run into some issues with our mono repo and application that we need to resolve real quick before we really get our hands dirty here. So let me go over to our Form Hub application. That's what we're calling this app. By the way, I've uploaded this to my GitHub. My GitHub is Mr. Wade. So if you go to GitHub/Mr. Wade/form-hub, then you can see the monorepo version of this application, which is what we'll be using today. The very first thing I want to go over is right now the Docker build is failing. So if you go, we have 2 apps in the Turbo repo here, backend and front end. If you go to the backend repository, or not repository, backend application, we created a script called rebuild.be, which runs all the various Docker commands you would need in order to rebuild this application. So if I do a yarn rebuild.be right now, it's actually going to fail. So we're going to fix that up before we move any further. The reason it's failing is, and it's a very strange error, it took a little while to figure out, if I'm being honest. It's failing on installing Turbo. And it turns out that something was added more recently than just a few weeks ago, and I did this video, that has Turbo failing on installing on Alpine Linux. In addition to that, since I recorded this video just a few weeks ago, turns out that Node.js version 19 has been released. I don't really want to use 19. Here's why. I mean, I'm all about the latest and greatest bleeding edge, but 19th is the bleeding edge. 19.0.0, it's the current version. Node 18 is the LTS version, which stands for long-term support. Oftentimes, if you're developing a production application, the LTS, or hint, even numbered versions of Node are typically what you want to use for production. Node's the only thing I know of that works like that. The even numbered versions are the long-term support, production-ready versions. The odd number versions are kind of where they do their experiments, and turns out something. Well, I guess it didn't break in Node 19. Turbo broke, but anyway, we're going to use the long-term support version, and we're going to fix this Turbo repo install at the same time. So let's go into, get my windows straight here. Let's go into apps backend Docker file. This is our Docker file that we went over in my last video, creating the Turbo repo monorepo. And we have a couple of different references to Node here. The first thing we're going to do is I want to specify a Node version. Instead of just saying from Node all over the place, let's do a from Node LTS. So I could say 18 here because I know that that's a long-term support version, but let me just go ahead and reference LTS, and that will go grab whichever LTS version is currently marked as, whichever Node version is currently marked as LTS. So be sure you change that in multiple places here because we have several different places where we are referencing from Node. The next item I want to update is this LTS Alpine. Within this Alpine scope here, or stage it may be called in Docker, I don't know that for sure. It may be called stage. Adding Turbo here is failing under Alpine. Now, it's a little weird that I'm mixing Alpine and non-Alpine versions within this same build anyway. So let's just not use Alpine at all. And I need to comment out this APK because we're not using Alpine anymore. Let's just not use Alpine at all. Let's use Node LTS all the way down the file for the build. So with those changes in mind, from the app/backend directory, let's run a yarn rebuild BE and just make sure that this rebuilds fine without any issues. Again, this isn't related to deploying to production, but I wanted to update you because this is an update from the last video. Things happen fast in the development world. So we'll let this rebuild here, then we'll run through a little test to make sure the application's still working, and then we'll get to going to production. I will have my coffee while we're fetching packages. I don't know any jokes for you. Okay, looks promising. Once this is done, this will try restarting our backend. Yes, I'm sure. Okay, looks like our backend restarted. We don't need the Node page anymore. Let's pull up our demo app. Let me refresh. Things load fine. Let me hit generate. The queued job is going. If I'm going to refresh, this goes from 41, hopefully do 51, 51. So the whole thing works now. We rebuilt and fixed our Docker file. So let's commit those changes real fast, and then we'll move on to deploying to production. So we're going to specify Node version and specify Node version and fix Turbo install. Is what we're doing here. Excellent. Okay, to production. We're going to be using Render. Render is a great hosting platform for applications of many different kinds. So Render does lots of different things. They can host anything from static sites to full-on web services like Node, Ruby, Python. They have several different types of services you can have here. That's what we're looking at. Private services are services that are not publicly visible to the internet, but that maybe you have some services behind the scenes, microservices, something like that, that your application uses. Then those are secured within a private network. Background workers, cron jobs, And then what's awesome is they have fully managed Postgres database hosting and kind of new to the platform, fully managed Redis hosting as well. Many different applications use Postgres and Redis, so it's really nice that they have these. You don't have to worry about backups or anything like that. It does it all for you. The other really nice thing about Render is this thing called blueprints. This is proprietary to Render, but it's a simpler version of, if you might know, the Terraform framework or Amazon's cloud formation, or even really just Docker Compose. So if we pull up our Docker Compose file, this is what we went over a couple of videos ago to set up our Docker environment, which is Postgres, Redis, and our running backend. Set up our Docker environment for hosting this application. Well, a blueprint within the Render ecosystem is, I've switched over to the docs file, so I went to docs here. And over here on the left of docs, they have blueprint specification. A blueprint specification is much like a Docker Compose file, but it's specifically for production, and it has a lot of Render special sauce in here. So what this does is you actually specify this render.yaml file in your code repository. And that helps to really document what your infrastructure is, what all the services are, what they connect to, the repositories, the build and start commands, environment variables, things like that. And as you need to update things over time, if you update the render.yaml file, push that up to your GitHub repository, Render then pulls that blueprint or render.yaml file automatically and updates your infrastructure accordingly. So again, a really great way to document what your infrastructure should be instead of setting it up all manually and perhaps with error-prone mistakes. So what we're going to do in this video is build up this file together for our, and it's not going to be this long. This is their example, kind of kitchen sink example. We're going to build up this render.yaml file together, set up our Node, Postgres, Redis, and front-end services, and see that deploy out to production. So without further ado, let's dive in. So the first thing I'm going to do is from the root directory, I'm going to create a new file called render.yaml. And let me pull this up side by side with our documentation. The render docs are great, by the way. They're simple but detailed. So I would highly recommend going through the docs here. I kind of have their sample blueprint specification pulled up, and we're going to roughly follow this down to create our spec. So the first thing they have is a services key, services. So I'm just going to kind of stub out our 4 services, and then we'll go in and fill in the details. So the first service is going to be a web service. That just means a public web service in the Render environment. Alternatives to this type would be like pserv. Pserv would be a private service. So same thing as web, it's just not publicly accessible via the internet. You give your services a name. So I'm going to name this Form Hub. I'm going to shorten that, abbreviate that. Form Hub. Then I often like to do either production or staging. You might have various environments all working within the same project or team here within Render. And then I'm going to name this backend 1. So, as you upgrade things, move things, change things over time, it may be necessary for you to build out whole new services. So I like going ahead and sticking a number on every service because you might end up with backend 2, backend 3 as you iterate on these backends. And then environment. So environment is a key where you specify how this service is built or what environment Render provides you. So one environment is a Docker environment. So this is where you would provide a Docker file for exactly how to build this service. So this really means that Render can run any type of service, anything that runs in Docker, that is, which is pretty much everything. So whether it's Ruby, Python, JavaScript, Scala, Java, whatever you want, if it can run in Docker, it can run on Render. But there is a convenience environment for you called Node, to where you don't even have to specify a Docker file. You can instead use Render's optimized Node environment, to where you push up your code and give it a start command and a build command, and pretty much just works. Now, there are two approaches you could really take to this because we have a mono repo going. We've actually already created a Docker file for our backend that we are using in our local environment. And technically, this would probably be the more appropriate, more exacting way to do this, because we're going to great lengths in this Docker file, thanks to the Turbo repo examples, of only downloading and installing the dependencies for each specific service. So in this case, we're scoping this file and dependencies and build just to the backend. There are some extra steps you have to take with Render to get everything in Docker working, specifically around secret files and a little bit environment variables. So you could choose to use the built-in Node environment or use a Docker file. Either one would work. There are pros and cons to each. In this video, I'm going to opt for just kind of the simpler version, which is just using Render's Node environment. The downside of this is when we install the dependencies, it's actually going to install the dependencies for all of our apps in the monorepo, but we don't have a lot of apps in our monorepo, and it's really not that big of a deal. So as you grow, though, you might want to do a custom Docker file for this service. So long explanation to say you can use Node or Docker here. Next up, let's just stub out the rest of these, and then we'll dive into detail. So next up, we want our React application. And we could do a web service like this and just have a web server that hosts our React application. But instead, we're actually going to generate this statically and then host it from there. So we're going to do type web, but the environment is going to be a static build. And we'll name this Form Hub prod frontend 1. Okay. Next up, let's do our Redis instance. So let's do type Redis. This is the fully managed render Redis. So again, you don't have to worry about backups, how this thing starts up, versioning, setting up the environments, anything like that. Just fully managed Redis at your fingertips. So we'll call this Form Hub prod Redis 1. And then next up, we want our database. So it looks like database is its own key in this file outside of just services. So let's create our new root level key here called databases. We don't specify a type. It's just going to assume Postgres. That's the only database they have available. Let's name this Form Hub prod database. I'm just going to shorten that to DB1. All right, so these are the 4 services we're going to have. It's not all the details we need. I just kind of wanted to stub these out and get them going. So let's circle back around and fill in the details for each different type of service. So let's start with our backend here. So it looks like each of these specify a repository. Now, like I said earlier, I did upload this to GitHub. So let's copy that in. We're going to deploy this application straight from GitHub. And in fact, we're going to do that for our static build too. We'll get to that in a minute. Region is optional. You can specify which region you'd like, but we're going to use the standard one. You can specify a plan. So this will be your pricing plan, really, for how much CPU, memory, all that sort of thing you need. It will start you at the lowest cost one. So again, that's optional. I'm going to leave that off. You can specify a branch here. So again, that's optional. I'm going to default to our main branch. But let's say you, within here, also did a staging environment. Then you may want to specify like a staging branch or some other branch that you're working on. Although render does have a really cool feature for creating staging environments from pull requests, but we're not going to get to that today. So the branch is going to be default. Root directory, we're going to leave default. This is not Docker. You can say a number of instances. So if you know you want to run several instances at one time, you can do that. You can do a health check path. And so this will be an HTTP path that render regularly calls in your application. If it reports a code 200, that's a success. It leaves the service running. Anything other than 200 or maybe in the 200 range, then it would actually boot up a new service because your service is unhealthy and try to fix it that way. Then you can specify environment variables. So let's get to that. Actually, we need our build and start command. So let's do that. So our build command, first, we want to install all of our dependencies. So we're just going to run yarn. And then we want to run yarn build to build up everything. However, because this is, remember, our mono repo, by the way, I'm referring to a reference file I have on the side for one of our production applications. So I'm making sure I'm matching this here because I've already done this in a few places. In our yarn build command, we just want to build the backend. So we're going to filter this down to the backend. And so this will run the turbo build and filter down to just building our backend. Now our start command, again, we're in mono repo land. So the first thing we actually want to do is change directories to our backend. And then from there, we can run a yarn start. So those are the build and start commands. Another thing you can specify in here is a domain name, so custom domains. It will go ahead and tie your service to publicly accessible domain names. I'm not going to specify that here, and it will just give us some render domains that we can use. Now for environment variables. Let's check out our Docker Compose file. Our Docker Compose file is what we're using locally. And I want to see for our backend service, what environment variables are we using? So it looks like we have a database URL, a port. Port is actually one that render automatically provides to your service. So we won't need to use port. And then we have Redis host. This is going to be a little bit of an issue, but we're going to fix this and have development and production mirror each other. We're going to improve this. So let's start with database URL. Now, locally, it's quite easy because I know that I know it says Postgres, Postgres, Postgres. These all three mean different things. This is the Postgres protocol. It's Postgres as a username at Postgres as a DNS name. So this is truly a URL. And for Docker Compose, that's the URL to the Postgres service. But in Renderland, I don't know what the URL will be. So Render has a really great solution for that. So let's specify our environment variables section in vars. And I want to make an environment variable called database URL. But instead of just specifying a hard-coded value here, they have this really nice thing. let's go to, I know it's called connection string. Here we go. I have this really great thing called from database. So instead of hard coding the value of this database URL, it's going to generate it for us automatically from the database that we're creating in this file. So from database, we have to tell it which database. We only have one, but we need to tell it. And then the property. So you may want to get from this database the host name or the password or the port or things like that. We actually just want the whole connection string. So that's what this special thing is called that we're specifying in our Docker Compose file. That's a connection string. It's everything it needs from protocol to username and password to host name to even the database name. Everything it needs in one string. So that is going to set up our environment variable database URL, and render will make sure that the appropriate connection string for our database is set up. Now for Redis, we're going to have to do actually a little bit of code change in our application. Redis has a very similar thing in that you can generate a connection string for Redis as well. However, right now in our application, we're only providing a host. So let's update our application to be able to use a Redis connection string and then locally, and then we'll set that up for production. So instead of Redis host, let's do a Redis URL. And it'll be very similar to this Postgres URL above. So it'll be the Redis protocol. It will be Redis, the DNS name. And then the port will just be the default Redis port, or the one that's for the Docker container, which we could, I'm sure, look up on Docker Hub, but I'm going to look up just on the side here for me. So the default Redis port is 6379. So that changes it in our Docker Compose file. But let's see where we were using Redis host in our application. So we were using that in our queue module in the backend. So we're using the Redis host environment variable and adding that into the connection object of our queue. Now, I don't know off the top of my head if we can pass a connection string to the queue. But I do know we can pass an instance of IO Redis. So IO Redis is, I believe, the library that is used under the hood of our queuing system. We're using BullMQ. So all that to say, what we're going to do is I want to be able to create a connection of IO Redis, pass it that connection string from the environment variable, and use that within our queue. So let's add in IO Redis as a dependency. So I'm in app/backend. Let's do yarn add IO Redis. That's going to add our dependency. Okay, while we're coding here, I'm going to go ahead and start a rebuild of our backend. Anytime you add or remove dependencies, then you do need to do a rebuild of your Docker container. So let's do Redis, and this is going to come from IO Redis. That looks good. We're going to pass in our connection string, so Redis URL. And I am going to add in this check up here to make sure we have a Redis URL available. Now, what is going on here? Why does it not like this? It looks like, let's see, Redis URL is not listed as a dependency in turbo.json. So it looks like for Turbo Repo, you are supposed to specify your environment variables in turbo.json. That's new to me. So I want to look into that in the documentation. It's not going to break anything right now, so I'm going to skip this and just kind of ignore the red squigglies. I know that's a little annoying. I'm going to ignore these red squigglies for now, since it's not specifically pertaining to deploying this to production, but I do want to look into that. But we're going to pass this string to Redis, and then we're going to use this connection in our queue. So we don't need this anymore. I'm not sure why Redis, type of Redis is not callable. Did you mean to include new? I did mean to include new. Thank you, error message. Okay, so we're doing new Redis here. We've got that. We did update our Docker Compose file, so I'm going to Control-C out of our Docker here to stop this and do another Docker Compose up. Looks like it's failing. And I'm not sure why. Okay. So it's trying to connect to Redis. I believe it's trying to connect to the wrong thing. Let me save this file. That is a bit strange. Let's Docker Compose, restart our backend, see if it picked up our latest code changes. It did pick up our latest code changes. Okay, that's good. We've got our Redis URL here. That should be correct. Am I getting any errors saying that the Redis URL is not specified? Let's see. Redis host not defined. So it is using an old, Redis host. Let's do Redis URL. Okay, when I'm saving here, this is another unrelated issue. When I'm saving, it is not restarting our instance for us. If I go into backend, I have this VS Code directory. Before we put this into a mono repo, we had this VS Code settings directory in the root of our backend. Well, if it's in the root of our backend, it's no longer in the root of the project within the mono repo. So let's move this folder to the root. Yes. And that will enable our settings for restarting the backend. And we want to restart the backend whenever our apps/backend files change. So if I do a save here, I would hope it would restart. Let me do a reload of our window. Let's see. I thought that was going to be a quick fix, of course. Restart web, restart backend. Okay, the task definition looks good. Apps/backend. That makes sense. Okay, there we go. So I hit save. It's restarting our backend. That's good. Okay, moving along. It looks like, let's see, let's look for our error. Redis host, it's still saying host. I did, in fact, change this to Redis URL. Let's see. Okay, so it looks like for some reason I had commented out our volumes in our Docker Compose file. This volumes is what allows you to map your local working code on your Mac or your Windows machine to the appropriate directory within the Docker container. I, for some reason, commented those out. I guess we didn't finish that in our Turbo Repo instance. Let's fix that as well. Lots of things to fix up here. We're getting there. Okay, in Turbo Repo, let me look at the directory structure here. So our directory structure is app, apps, backend. It looks like we do need to update our volume specification. So this is saying within VS Code and in our local workspace here, map app/backend to, we need to change this here. So this needs to match this value. So let's do app/app/backend. And then same thing here. We're creating a volume for our node modules directory, so it doesn't use the same one as our Mac. So let's do that. I think that will fix our volumes. Again, we need to restart Docker Compose. This looks better. Okay. We're not getting the connection errors now, which means it is pulling our latest source files, which means we did fix the volumes. Whew. Okay. Fixing lots of stuff today. Okay. I'm going to close all these windows. I do want to, we've made a lot of changes here. I do want to commit some things as we go here because I'm kind of working on a number of issues at the same time. So the first thing we're doing is we're moving all the VS Code settings to the root. So let's add in all of those. Oops. There we go. Okay, so move VS Code settings to root. What is this? Oh, we added IO Redis. Not yet. Okay. Okay, next up, I do want to say, I'm going to go ahead and make a separate commit for fixing our volumes. So let me, if you can, this is a cool trick. In VS Code, you can just highlight things and say stage selected ranges. So I only want to stage that range of changes. I like having like smaller commits when possible for like individual fixes. So I'm going to say fix volumes, backend volumes for mono repo. Okay, we got our volumes fixed. We can continue on with our quest to update our queue to Redis URL. It looks like that is working now. Let's test that out. So let's go to our application. Let's refresh the page here. Okay. Application's loading, so database is working. We're going to hit the generate button here. I see things moving in the log. We had 51 submissions. If I refresh, we have 61. This button queues up a job in Redis, so that means Redis was working. And it could be connected to from the backend. Okay, we're doing good. So all that means is within Docker Compose, we now have Redis URL, and our application responds to the environment variable Redis URL. Now, in our render.yaml file, we can do the same thing. We can use a Redis URL for our full connection string. So environment variables for our backend, we're going to say key Redis URL. And then instead of from database, we're going to do from service. From service, name. We're going to give it the name of our Redis service. And then the property we want, again, this could be things like host, port, things like that. But we're going to take the full connection string. Let's check our Docker Compose file. Database URL, Redis URL, and then port, like I said, is automatically provided by render. So those are all of the environment variables that we need for our backend service. So that should take care, I believe, we'll see if it works, that should take care of everything we need for our backend in this file. Now let's move on to our front end. Okay, so it's a public web service. It's going to be a static environment. We've given it a name. Let's do our build commands. So let's look at the example here for a static site. So it has a build command. So let's put that in. Build command. Again, we need to run yarn. And then let's do a yarn build, but this time scope it to not the back end, but the front end. Now there's no start command because this is not going to be a running application. It's going to be a static build. So let's go to our front end. And our front end static build goes into this build directory. So let's specify this here. So we've got static publish path. Just like theirs, it's going to be the build directory. Okay. Now, we don't right now have multiple URLs within our build here, but let's say we did. Let's say we had a different URL here. And let's say that it was even dynamic. So let's say we had forms/form1234. We're not going to have a file for every dynamic page here. So we really want the same page, the same HTML and JavaScript served up for any path. That is something we can specify here in the render file as well. They have a really great system for routes in static directories. And I'm gonna copy this in from an example I have on the side. So from this service, we have routes. So we're going to do a rewrite type of route. If you're familiar with, it might be Nginx routing. I could have that wrong. If you're familiar with different type, or Apache, I'm not sure. If you're familiar with rewriting URLs in various services, then this is for you. So we're going to rewrite all routes just to our index.html file. So no matter what route you put in the URL, it's going to serve up the same HTML so your application can load. I hope that makes sense. That may be all we need for our static page as well. Actually, it's not. Let's check. We do want to specify our GraphQL path. So our application needs to be able to call our backend to make GraphQL requests. So let's go to our front-end application, and let's check out where this might be set up. So in our front-end application, we're creating a new Apollo client, and we have hard-coded here localhost. Now, of course, that's not going to work in production. So we need some sort of specification here, or environment variable we can pass in to provide a URL. So let's create one. So let's say let's create a variable called URL. And this is either going to be an environment variable called GraphQL URL, or if that's not set, we'll just go ahead and use this hard-coded version. So in development, we're not going to set this in development. It will just use localhost by default. But in production, we'll set this up to where at build time, it will put in this URL. Okay, so and we did save and this refreshed automatically, so this is still working. So let's specify this GraphQL URL in our render.yaml file. So let's do invars key GraphQL URL. Now, off the top of my head, I'm not sure what this is going to be. I know it's going to be something. Okay, environment variables. Let's check this out. Okay, so Postgres databases, Redis instances, servers, and cron jobs. I want the publicly accessible domain name is what I want. If it was a custom domain, I would be able to put that in here. Let's try using host. I think that's going to be what we want. Let's try using host. Okay, so we're going to do from service. The name of the service is going to be our backend. The type of our service is a publicly accessible web service. And the property we want is the host. Although now that I'm thinking of that, that's only going to be the host. It's not going to be the full URL. So I'm going to rename this variable to GraphQL host, and we're going to switch this up a bit. So if GraphQL host is available, then we're going to specify that the URL is HTTPS, give it the host, and GraphQL. Because we need the full URL here, not just the host. So let's try this. We definitely want SSL in production, so we'll use HTTPS. Let's see if that ends up being exactly what we want. Again, if I were using a custom domain here, and I knew the backend's custom domain, I would just use, API.myservice, whatever it is, .com/GraphQL, and maybe just go ahead and do the GraphQL URL here like this. Let's try out this host method. Okay, so we have, I think, our static site built up. Let's move on to Redis. So let's take a look at our Redis. I don't think we're going to need to do anything in Redis, although there are several Redis configuration options you can set up if you want to specify things. So you can specify different policies, again, different plans if you need more memory, things like that. IP allow list, so if you need to allow your Redis instance to be accessible publicly, things like that. I think we just need this. And then our databases, similar thing here. I don't think we need any customization here. We will just use the defaults. So this looks pretty good. Oh, we didn't specify a repository for our front end. So let's go ahead and do that here. It's the same repository since it's a mono repo. But that tells me that static publish path, it's not just build, it is apps/frontend/build. I got that wrong. Okay, last thing in our render file here, because this is a mono repo, And because we're using the same repo for multiple services, anytime you push a commit up to this repo, for every repo that, for every service that is using that repo, render will rebuild the service. But sometimes you only change things in the back end, or you might only change things in the front end. Then render has this really great thing called build filter. And this is great for monorepo environments. So for instance, we only want to rebuild and redeploy the backend if we make backend changes. And we only want to redeploy and rebuild the front end if we make front end changes, not redeploy every service for every commit ever. So they have a build filter. So I'm going to specify that here, build filter. So that means whenever a commit's pushed to Form Hub, we only want to rebuild and redeploy this service if something was changed in the apps/backend/anything path. If something didn't change in the backend, we don't need to redeploy this service. The same thing goes for the front end here. We only need to redeploy this service if something changed with the front end. So I think we have a pretty good start here to our render file. We'll see what we missed when we deploy. But let's go ahead and commit up some changes here. So we have our Redis changes. We installed IO Redis. That's good. We updated our queue to use Redis URL. We updated that. I'm going to put these in a separate commit. So update Redis setup to use Redis URL. And then we're going to add our render config. Add render.yaml. Okay, and I'm going to sync those up to GitHub. Okay, you ready? We're going to try pushing this up and see what happens. So I have already gone in and I created a team within Render. So this kind of gives us an environment to work in. You'll have to put in your credit card. These are paid services. And like I said, I've also pushed this up to Mr. Wade/Form Hub. And we pushed up our changes here. So this has our latest commits. So let me go to Render. I'm going to go to the blueprint section. And the blueprint is this render.yaml file. So we're going to attach this Mr. Wade/Form Hub to this render team. I don't think I need that. We're going to use the main branch. It's showing that field path not found in build filter. Did I get that right? Oh, this is supposed to be plural. So I missed that. Okay, this is supposed to be plural. So instead of path, it's paths. So let's fix that. Fix paths key. So thankfully, it is detecting our errors here. So let's do retry. Okay. Services, let's see what failed here. Services, envars, from service type, empty but required. Okay. So looks like from service, we didn't have a type here. Okay. So from service, we have a type on this one, but no type on this one. So let's do type Redis. That should fix that. Services 2 must specify IP allow list. So that is showing that for our Redis instance, we do in fact need to specify an IP allow list. So I actually don't want anything allowed from the public internet. So let's take a look at this. And we can set this to an empty array so that it only allows internal connections. So IP allow list, again, let's double check that. Services 2, so that's the second index, so that's our third item, backend, static, Redis. So we do need to specify an IP allow list here, and this is just going to be an empty array. So we are fixing our environment variable and fixing Redis. So fix Redis config. Let's sync that up, and let's do another retry. Okay, so it looks like we've gotten rid of all of the obvious errors from our render.yaml file. So this is detecting that render needs to create a database, create a Redis instance, create a web service, and create our static web service. So we're going to hit apply here. Oh, service group name. We'll call this production. So now render is going to go through and actually start creating these services for us. And you can go ahead and start clicking on these and see what it's doing. So the database, status creating, that's good. Excellent. If I go back to my dashboard here, we can see it's already created our Redis instance for us. The default region is Oregon. It's using Postgres 14. Let me see if that's what we're using locally. We're using 14 locally as well. That's good. Okay, so database and Redis are available. Let me refresh, see if anything else is coming in. So our backend is now deploying. So let me go to our backend. And let's click on deploy, and we can actually see this build working. So downloading cache, still downloading cache. So this is downloading the repository. It's running our build command, so it's running yarn and installing our dependencies. This is one of the great things I love about render is it's really easy to navigate. There are not a lot of screens here, and they're all very useful. So I can click in 2 clicks here, I can trail the logs and see exactly what's going on in my deploy. I can also see, if I go back up to blueprints, I can go to this blueprint we just created, look at the syncs, and I can see the progress of the sync it's doing from our render.yaml file. So let's go follow the backend deploy and just make sure everything's working here. Okay. Lots of infos and warnings, but that's to be a bit expected here. One interesting thing too is that render does cache these builds and deploys. So this first one will take a little longer, but then subsequent builds will build from a cache, so they get shorter. I can also see that render has selected this URL for us. You automatically get a URL for your public services, which is a subdomain of onrender.com. So this is going to be the URL of our API. Let's go over to, let's see, here we go. Okay, so we successfully installed the dependencies. Now it's running the build. I do see it's running both the front end and the back end build, which is not quite what we wanted. For some reason, we have 2 filters in here. That's weird. That sounds like our fault. Let me close my blinds a bit here. I'm kind of bright. So I think that's probably our problem. Let's take a look at our root level package.json. For some reason, I put filter front end, in our root level package.json. Why I did that, I have no idea. That sounds wrong. Okay, let's get rid of filter front end. Yeah, that really shouldn't be specified there, I don't believe. Okay, so remove default build filter. Sync that up, push that up. Okay, so I just pushed up another commit. That is probably going to interrupt this build. We will see. Let's go to our dashboard. We now have a front end going. So here's our back end and our front end. We can see our blueprint is still syncing here. Our back end, is it still deploying? It is still deploying. Okay, now that's interesting. It did not start a redeploy here. And if you think about it for a second, it did not start a redeploy because nothing within our apps/backend directory changed. We changed the root level package.json file. So that is operating as expected, or at least as we configured. So it's finishing up the build here. cd app/backend. I'm having trouble with plurals today, apparently. That should be apps/backend. Let's check our other one. Apps. So I did specify that there. Okay. Here we go. So fix start command directory path. Okay, so that should be fixing that. Our deployed failed. I don't know if you saw that, but it first marked our deploys failed, then it restarted because we did push up a newer version of our blueprint. We can see that it successfully updated our backend to a new start command. So that's one of the things I really like about this render.yaml file is everything is documented as far as how our infrastructure should be set up. So let's say we wanted to then go create a staging environment. You don't have to remember, because you'll never remember, everything you did to create a staging environment. You have everything documented in the render.yaml file. So let's go back here again. Let's check out our backend deploy. It has started. It downloaded the cache that we had. So it downloaded the cache. This should make fetching dependencies and maybe building faster. So that's going to go there. One thing I want to check out is that GraphQL host that we created for the front end. So let's go to the front end service. The front end is still deploying. And let's go to our environment variables. So here's where the GraphQL host variable came in. And it kind of visually hides your environment variables here until you hover over it. So let's hover over it and see what it was. Okay, so this is a partial URL for what we need. So fhprod backend 1. So that is the internal DNS name for our service here. I'm a little surprised that and maybe I'm just not seeing it in the documentation here. I'm a little surprised that there is not a property for the public URL. And maybe I'm just missing it, but it looks like host port and host port are the available properties. Maybe I'm just not seeing it. So again, this is going to be a little bit manual, but not too bad. So I'm going to need to go in and fix that in our front end. Not that file, this file. So this is going to be, it's really going to be our subdomain. So this is going to be fhprod backend1 on render.com. So again, if I were using a custom domain, I would just put the custom domain as the environment variable. But let's go ahead and just add this here on render.com. So it's our host, HTTPS, on render.com, GraphQL. Okay, so fix, GraphQL, production URL. That should trigger a new front-end redeploy because we did change a file in there. Okay, looks like backend may be failing now. Okay, this is okay. This is fine. So everything started up. That's fine. But it says table public submissions does not exist in the current database. Well, it's a brand new database, and none of the migrations have been run. So let's take a look at how we would run migrations in Render. So let's go to our backend instance, and they have a shell tab here, which is great, because we can pull up a shell of our service. Now, because it may not be running, so I'm curious as to whether or not the shell will come up. Okay, it will. That's nice. Okay, we're running node 19 again for some reason. That's because we didn't specify a version, I'm guessing. We did specify a version in our Docker file, but that's only for local development. So we probably want to specify a node version in here. So let's look at node. I'm sure there's a way to specify a version. That might be specifying it in your package.json file. That would make sense. Am I specifying that in here? I am specifying it for Volta, but that's just for Volta. I probably need to specify this for engines as well. Let me take a look at one of my references here. I think that is what I need to do. Okay, so let's do the same thing. We've pinned this Volta version to like 18.7 in this case. I'm going to go ahead and put a caret on this one. Let's go ahead and do the same thing, but for engines. And this should specify which version of Node that we're using in production. And I want to go ahead and just specify the latest version of 18. So 18.12 is what I'm expecting. Okay, so specify backend node version. Okay, that's good. Where were we? Okay, we were fixing, letting various things run and fixing things as we go here. We were fixing the fact that there are no database tables. So we've gone to our backend instance on Redis to shell, and we need to run some migrations. So let's just do yarn. Actually, let's do ls, see where we are. Okay, so we're in the root level of our monorepo. So let's go to apps/backend. And let's take a look. We have a script for dbmigrate. This is going to run our database migrations. Perfect. So let's do yarn dbmigrate. Next not found. Interesting. We do have it as a dependency. It's trying to run next as an binary. I probably need to do npx next migrate latest. Let's try that and see if we need to update this script. So let's try npx next migrate latest. We may just need to update the script. npx is a nice utility to run node package binaries. Okay, a different error. We're getting further. It's failing to load TS node. So because our migration files are TypeScript files, it needs to compile those as it's running. I'm guessing TS node, we made it a dev dependency instead of a straight up dependency for our application. So let's change that and add TS node as a main dependency. It's also failing to load things like TypeScript node, all this. So we do need all of these dependencies in production for for the purposes of running these migrations. So let me go ahead and move up. Actually, not need anything else here. Let me go ahead and move up these. Let me go ahead and move up TS node here. Okay, so fix migrations in production by adding npx and TS node. There may be another step we need there, but we'll see how far that gets us. Okay, so this should trigger, again, another redeploy. So we're getting the deploy going here. We're needing to run migrations. It looks like our database and Redis instances are available. It's saying that our front end succeeded. So while the back end's deploying, let's check the front end. So I can click on this URL and see if our front end's loading. This is a trick. It looks like it's working. I can tell you it's not. So our front-end code is in fact loading. However, it's being a little sneaky. I happen to know that if I look at this, it's loading GraphQL from our local host, which is running from our Docker. We don't want that. So the environment variable failed to load at build time. I know what I did wrong here, and that is how environment variables work in Create React App. So our front-end application is a Create React App application. And environment variables can be leaky. So, there can be some pretty sensitive information stored in environment variables. For that reason, Create React App has a very specific way you have to name environment variables. So let me show you where to find that. So Create React App environment variables. Anytime you create an environment variable in Create React App, it needs to be prefixed by React App. Because all environment variables, aside from ones prefixed with React App and just the node in variable, are not available. So whenever we specified our GraphQL host, that was not available. So let's go to our render.yaml file first. We're specifying this environment variable GraphQL host. Well, that's not going to be available. So let's prefix that with React App. GraphQL host. That variable should be available at build time. So let's go to our front-end application as well, app.tsx, and update this. So we're using React app GraphQL host. That variable should be available. So we are fixing our environment variable. Fix GraphQL URL envar. Alrighty. Now our front end will redeploy. Perfect. And we can see along the way, every time we make a change, it's syncing our blueprint for us. So we can see that it created the environment variable React app GraphQL host. Now, one thing that the render blueprints or render.yaml file does not do is it doesn't do anything destructive. So technically what we did is we, in this file, deleted the GraphQL host variable and added the React app GraphQL host variable. But because render doesn't do anything destructive, if I go into the front end here and look at our environment, I should have two environment variables. So it's not going to automatically remove things whenever you remove them from your YAML file. So that's a good and safe thing to know, is when you delete things from the render.yaml file, unless you replace it, with something that overrides it, it's not going to delete things from your environment. So I'm going to go ahead and delete this variable because I know we don't need it. Okay, still jumping around a little bit here. Let's go to our back end. Let's look at our deploy. Found incompatible module. The engine node is incompatible with this module. Expected 18.12 got 19. Detected node version 19. Sometimes, if you change up your environment so much, you need to clear the render cache. I'm not 100% sure that that's what's happening here, but it might be, and let me show you. So up here in manual deploy, I'm going to say clear build cache and deploy. So the cache was using 19, but we updated our package.json to use 18. So let's clear the build cache and deploy. I hope this is helpful for you, because this is just kind of what happens when you try to deploy things. You got to get all these little details right. And so I hope going through this live like this is really helpful. This is pretty much what happens. Okay, so it's still detected node version 19. Why? I don't know. Okay, so render specify node version. Aha, specifying a node version. Add an environment variable called node version. Okay. Add a file called node version. Add a file called nvmrc. So if we were using nvm, which I used to use nvm, now I use Volta, then it uses that. Alternatively, you can specify a node version in the engines directive in the package.json folder. Now, I did that. Sorry, I touched the mic. I did do that. Why did it not like that? Did I do it in the wrong place? Ah, I did do it in the wrong place. Okay. I did it where I thought would make sense, which is the backend package.json file. However, this is a monorepo, so it's going off of the root level engine specification. So I'm going to move this to the root level package.json file, which is specifying an engine, but it's saying anything over 14, which is quite vague. So let's change that to 18. Alrighty. Okay, so we are specify node version. Okay, so that will fix our back end, or it should. Okay, if we go to our events here, the backend's redeploying. Okay, that's good. All right, so we are redeploying our backend. Flipping back over to the front end now. Let's see why this is angry. Okay, same sort of thing here. Expected 18, it got 19. So that should fix itself as well, although we didn't change anything in the front end directory, so it didn't redeploy automatically. So I'm going to go ahead and do a clear cache and deploy here for the front end. And let's see if it correctly detects to use node version 18. Okay, 18.12. That's good. Okay, so that's going. Let's go to our backend. It should be the same thing. 18.12. Great. Isn't there a war in 1812? The War of 1812. Okay, so we are redeploying. So we fixed our node version. We have added the dependencies we think we need to get migrations running. So when this backend has been deployed or at least built, then we can pop back over into the shell and see if we can run our migrations, which will create our database tables for us. Okay. Let's look at front end. How's it going? It's still going too. Okay, we did turbo run build, filter backend. Okay, we fixed the build command, so it did only build the backend now. That's good. Uploading build. Okay, so the build was successful on render. Great. Now it's deploying it. Usually, you can see the server start up here as well. So we'll see if the server starts up. I would expect more errors because the database tables don't exist yet. And as soon as this is deployed, this will end up saying live if it's successful. And we'll open up the shell to run our database migrations. If I go to the shell now, what happens? Node 19. Okay, so that's still an old version. So you have to wait for the build to fully finish before you're able to open up the new shell. So this is still going. Okay, was able to change directories. That's fine. Okay, was able to change directories into the proper directory. I fixed my pluralization. Ran a yarn start, and it started. Looks like it tried to start, but we're getting database errors because, again, our database tables don't exist. That's okay. So let's go to shell. Even though the service is experiencing, or the server is experiencing errors, I think our shell should be updated now. Okay, now we're on node version 18. That's good. So now let's see if we can run our database migrations. Okay, let's go into our apps/backend directory and do a yarn db migrate. That runs npx next migrate latest. So we didn't get an immediate error. Let's see if this is successful. Now, in your shell environment within render, okay, we're still having issues here. In our shell environment within render, it does have your environment variables available. So in order to run your migrations, your code needs to be able to connect to the database, and so it needs that database URL, and that is available here in the shell, which is good. Try running npm install next. Okay, I'm really not sure why it's so angry about this. Let's see, ts node register. Let's look at node, let's see, ls. Huh. Not sure why that would be upset with us. Let's go to our root. Okay, for some reason that I'm not sure why, it doesn't have our dependencies installed, it looks like. I'm going to run a yarn from the root. You don't typically have, like, because I'm not seeing a node modules directory. That's the issue here. I'm not sure why I'm not seeing a node modules directory. So I'm going to run yarn from the root. I shouldn't have to do that. So I think that's highlighting the fact that we have another issue here. But it may be because the build didn't fully succeed. Let's see. While this is running, let's again flip over to our front end here. Okay, so deploy live. So this means the build fully succeeded. When it ran our build, it properly filtered to the front end, so it only built the front end. It didn't build the back end. It says the site's live. Let's see if it is or if it's lying. Loading failed to fetch. Okay, that's actually what we want. That's fine. So this means the React application is loading. It's able to download the proper HTML and JavaScript files that we need to run the application. That's good. What's failing is GraphQL. So CORS error. Oh, CORS. Oh. That's CORS error. Lovely. Okay, let's see. CORS error. Yes. Okay. So it is trying to connect to the backend, but technically the backend is on a different domain. It's not on a different top-level domain, but it is on a different subdomain. CORS, lovely. Okay. Let's go to our backend source index, and we're using Express here for our server. And we've added our Apollo server. So we need to fix CORS. So there's this lovely package called CORS. And I think we just have to add it. Enable CORS per single route, configuring CORS, origin. CORS is really to protect your application if you don't want it being called from domains other than very specific domains. I really don't care who calls to our GraphQL API, so I'm just going to do this. So let me install CORS from app/backend. So yarn add CORS. Oops. Could not parse version 18.12.0. Okay, so that's via Volta. So in our backend file, I added this caret to the Volta version. Apparently it doesn't like carets. Sorry, Volta. Let's try this again. Okay, so let's yarn rebuild BE because I added a package. So we've got Morgan for our logging. Let me go ahead and add in cores here. We've got that there. Okay, so this is rebuilding our backend. Okay, we fixed Volta version. Oops, that also added the cores package. That's okay. Let's just make sure that this build succeeds locally and that the server boots, and then we'll make this commit and push this up. Production's fun, right? Okay, before I push that up, we were in process on packages for our shell here. It looks like it's slowing down. Oh my goodness. I have not had to do that before, where you run yarn just right in because your dependencies should be available. I'm trying to think of why that would be. Okay, so this restarted, servers running. Let's look at our local host. Local host is working. Okay, so we've added cores, and that looks fine in development. Add cores. Okay, let's look at our dashboard and see what's going on. Okay, so our backend is once again deploying. It's downloading that cache. So our front end is loading. So it properly built and it's properly serving up our static assets. From your browser, it is now trying to make a call to our backend URL, which, by the way, has properly been specified. So that means that when we prepended React app to our environment variable GraphQL, so now it's React app GraphQL host, then this URL was properly generated upon build. So environment variables and everything on the front end side seems to be good. So front end's good. So now we're just on the back end. Great. Okay, back end, still building. We're fetching packages. This will be a great time to, if you haven't already, consider subscribing to my channel. I'm almost at 1,000 subscribers, which is a heck of a milestone. That would be really awesome. Next month is actually my 2-year anniversary of this channel, if you can believe it or not. So that I've had a lot of fun doing this. This is great. So I appreciate your subscribe if you want. Okay, we've built. We're uploading. Man, I love that SWC compiler. 24 millisecond build. deploying. It will start up the server. We will get an error. That's okay. Still doesn't have database tables. The reason it usually wouldn't notice that we don't have database tables. It only notices when it tries to do a query. And the reason it's noticing is that whenever the backend starts up, I have this seed database function that runs. So if there's no submissions, it just goes through and creates a submission for us. So that's why it notices when it starts up. Okay, started. It's saying that this failed. Okay, so the server keeps failing, and that's because this is throwing an error. So let's go to our shell. Let's see. I still don't have node modules here, which is odd. It may be because the service is failing. Okay, now this is freaking out on me. It may be because the service is failing. So you know what? I'm going to remove this seed function. We don't need it anymore. I think that was really just a test up front. So I'm going to remove that. Remove automatic database seed. Okay. So that is pushing, or it should be. We're now redeploying again. Lots of redeploys today. Let's check out our environment. Let's check out our environment variables while this is deploying. So we have two environment variables that we specified in the render.yaml file, and it was to automatically generate from the connection strings. And so we can see here, and I may end up blurring some of this out because it's showing a password in here. I don't know if that's publicly accessible. I don't think it is, but I may blur some of this out. It's automatically generating our Postgres deployment, or our Postgres connection string, and our Redis connection string. I don't think that's publicly accessible, so that's fine. Not that this is much of a real service anyway. Okay, still deploying. I'm wondering if that node modules, really am wondering if that node modules folder isn't showing up because the service never fully succeeded. This it shouldn't fail on server boot anymore because it's not trying to automatically seed. So it should go live now, and we shouldn't get any errors because nothing's automatically connecting to the database. Okay, the dependencies downloaded, the backend built. So it's uploading, and it will be deploying shortly. Then now we'll see the server starting up. Deploy, deploy, deploy. Earlier, before I started this video, someone was playing bagpipes outside, so I'm glad the bagpipes went away. Or else you might have had some background music to this video. Okay, starting service. Yarn run, no dist, your service is live. Excellent. So server ready at, it's saying localhost, but I think that's just what I have hard coded. Yeah, localhost is hard coded in the log. Bool is giving us a warning that we need to specify some options that, okay, that's fine. Your service is live. That's good. If I go to events, it says deploy live, server healthy, finally, thank you. Okay, let's go to our shell now that things are healthy. Let me do an ls. Okay, now we have a node modules directory. Okay. So that's good to know. So if the service does not fully deploy, it looks like you kind of only get like a half shell here. It will be the latest version of your app, but it won't have node modules. That's kind of weird. Okay, but now we have node modules. Let's go into app/backend. Let's do a yarn db migrate. I wonder if that means if we didn't need to move TS node up to dependencies, if we could have left it in dev dependencies. Probably. Okay, requiring external modules, that means it's available. This is looking more promising. Okay, excellent. Okay, so it has run our migrations. That means they should be available. So let's go to our logs tab here. This means this shows that we can just trail our logs here in here on the back end. So I'm just gonna put this up here. That's our local host. This is production. There we go. Okay, so I'm gonna refresh. Okay, this is pretty exciting. So I can see that it was able to call GraphQL. The payload was a query. The response was a proper data structure, just with no submissions, because we don't have any submissions. The React app loaded here. I can see here in the backend logs, it was able to do a database query successfully. Great. Okay, so now I'm going to click on Generate Submissions. Generate Submissions calls a GraphQL mutation to the backend, queues up a job to generate submissions. That means Redis has to be working, our queue worker has to be working, database has to be working because it pushes in submissions, and then we'll refresh. So if I hit Generate Submissions here, we should start to see things happen. The logs may be slightly delayed. There we go. Yeah, the logs are slightly delayed. Looks like we're calling some deprecated functions. That's okay. That's a warning. We'll probably want to fix that later. But we did generate things. So if I refresh, now we have things. Now, let me confirm. I mean, I can see here in the logs that it's calling the proper production application. But just to show you here as well, it is calling the backend on render. So it is not calling my local host Docker anymore. In fact, if I go to Docker here, if I go to VS Code here, let me Control-C out of my Docker. So nothing's running in Docker now. If I do a Docker PS, nothing's running. I refresh here. This is properly loading from production. I can refresh. There will be 20 now, 20. So we have a fully functioning application in production. Postgres is running and working. Redis is running and working. Our back end is running and working. Our front end is running and working. And they're all communicating with each other together. It took quite a few steps to get here. You definitely run into things and little issues along the way, but we were able to work through all of them and get all of them solved. So again, all of this code is now public, so you can access that on Mr. Wade/Form Hub. It's all here. So anytime you want, you can come in here, reference this render.yaml file for how you might deploy things to production. And yeah, that's pretty exciting to, that's not it. That's pretty exciting to see this running on production. So I hope you've enjoyed this video. This is a video I've wanted to make for a long time, is getting this full stack up into production. I hope this was very helpful for you, and I enjoyed doing this with you live. So anyway, I hope you have a great day. Check out some other videos on my channel, and I'll see you next time. Have a good one.